Today we are start with module 4, that is embedded system design. Embedded system design, it is a specific applications which is useful for the microcontroller as well as microprocessor. So combined which is form a embedded system design. Design is a most important parameter for anyone engineer because so many languages are there, so many softwares they are using, but embedded system is a special class of design. It is totally related to the specific application. For example, in day-to-day market, you will observe several electronic goods which is related to embedded systems or microcontroller based systems. So that is useful for specific applications. So many toys are there, washing machine there. Nowadays they are introduced almost all systems such as a washing machine as well as a microwave oven. So these are very few examples of these embedded systems. So these are meant for the specific application for specific design is there. But it is not a general purpose design. So that architecture is also same thing, but we are learning the characteristics of embedded systems. First one is specific characteristics. Specific characteristics, it is you can define a specific characteristics or specific applications only you can utilizing this type of characteristics. So what are the important characteristics? If you take any one system, first our job is to analyze the components. It may be related to current, or it may be related to voltage, or it may be related to power, or it may be related to cost, and it may be related to the efficiency. So many parameters we are going to learn one by one, which is known as a characteristics of a system, or characteristics of a component, electronic components. It involves, it governs both software as well as the hardware. Combined, we can build a system. So that system specifications and its characteristics can be analyzed one by one. Very first characteristic of this embedded system design is, first we are going to learn about application domain specific. What is application domain? Application domain means there are several types of applications are there. Sometimes system level applications are there, and sometimes electronics goods, home appliances are there. So many applications are available. So the specific application domain specific, any software and hardware we are designing based on the nature of the device. So for example, you can take air conditioner. Air conditioner we can design certain hardware as well as the software, but we cannot use the same software for washing machine, because washing machine design and development structure is different as compared to the air conditioner. So you cannot replace it one into another. Hence the name itself is application domain specific. Once you design a particular applications, you cannot alter it. Only we can utilize only one function. You cannot replace it into other functions. So it is no. For example, you can take air conditioner cannot be replaced by washing machine. And another important characteristics of embedded system design is reactive and real time. Reactive is most important, because reaction, how much the system is response based on the input. If you give a input, how quick it is respond. The embedded system, more reactive operation, input and output is most important, because it is a reactive and real time. Reactive occurs nearby environment, depends on the situation, depends on the nature of environment. The system should be very reactive based on the input information. Then you will get the real and quicker real time results. For example, you can take a flight control system. Flight control system, what happens? Your embedded system is failure to control that. Suppose it has a more delay. More delay is not suitable for flight control and other systems. If the delay is more, what happens? We cannot control the flight, because a fraction of second or fraction of nanoseconds, the system will be destroyed. So if you create a more delay, the system will be damages. That's why without delay, this system is more reactive and real time. So this type of software is more suitable for remote control, flight control, anti-lock effect system, air conditioning adjustment, name a few. So many examples nowadays in the open market, the things are available. If you goes on continuously, you are observing, then you will realizing what is embedded system, what are its application at present market, what is the requirement, how much it is reactive and real time. You can take several, microwave oven is there, washing machine is there. So many examples are available, and products are available based on the embedded system. So hence this is more reactive and real time. This is most important, because so many speed control, vehicle speed control, if you apply the brake, if you immediately apply the brake, then there is a chance of avoiding the accident. Otherwise, if delay is happened, accident will be happened. So that's why vehicle movement control and all those things, the response and more reactive operating system, more reactive system design is very essential. Hence the it is more reactive and real time. And you will enter to the another important characteristics of embedded system, which is known as operational and harsh environment. Harsh environment means in any adverse effect, suppose depends on the temperature, depends on the environment. For example, very high temperature is there, at that time you can accept the signal from sensors. So the system should be cooperate, depends on the nature of the environment. Sometimes some temperature, very high temperature area is there, very high humidity temperature are there. Based on the nature of the environment, we are fix the sensors. That sensor is properly act and bring the input to the embedded system. So that the characteristics is most important in embedded system design. And fourth characteristics of embedded system design, that is known as distributed. Distributed means a embedded system itself is a larger system. The each components are independent each other. So totally independent. Distributed means total that each section is independently working, just like autonomous systems. So then you will get a quicker result and faster distribution of the information, or distribution of the file, or execution of the results in real time. You will get the result very quicker. For example, you can take automatic vending machine. Vending machine is there in mechanical systems. Another best example for this type of distributed system is ATM. ATM means day to day you are taking the money. Then automatic teller machine is examples of embedded system design. So we will come to the another important characteristics number 5, small size and weight. So almost all the peoples or the customers, they are required lightweight and compact cost, or effective cost, and most lightweight the peoples are prepared. So embedded system which is provide such type of a facilities. For example, you can take all the cell phones, all the Android applications, they are required very small. Those are the compact device, small size, and limited amount of memory which is required, and easy to carry one point to another point. So this type of market, that present day, the customer required lightweight and effective cost, as well as more quality products. But embedded system which is provide the such type of a requirement. So small size and weight is also most important characteristics of embedded system. And you come to the another important characteristics, that is power conserve. Power conserve is most important. If, for example, you can take a embedded Android mobiles, every day it consumes huge amount of power, because that power consumption is depends on how much application you are executing. Yeah, you can access through the internet. You can how much power is utilized, and based on the power, heat dissipation is the another parameter. How much power heat is dissipation. So these two parameters, design engineer should be consider these two parameters. Utilization, as also we have to minimize it, and it should not be generated more heat to the system. These are two important characteristics we can apply in the embedded system. So now we will enter to another important characteristics, that is quality attributes. Quality is a major important characteristics in all the IT as well as the OT systems. They are prepared the quality products. Quality means we have to build a product according to the international standards that should be very compact, and you can your design should be universally utilizing, and the quality everybody is expected the quality of the product, it should be more long life and low maintenance. So many parameters we can consider in the quality attributes. So there are basically you can classify it into two types. Number one is operational quality attributes. Another type is non-operational quality attributes. So in operational quality attributes, number one is the response. So now I am designing one embedded system that should be very responsive manner. Whatever the input results, that should be tracked very quickly and bring the results, display the results very quickly. That is also a real time. Then the response is very fast. The people's nowadays, the customers are required quick results, and that is also real time is most important. For example, you can consider flight control. Flight control system is it requires a very huge amount of quicker results. Without delay, we can send the signal and receive the signal. Otherwise, lot of damages will be happened. More delay causes more damages. So they are prepared this type of embedded system. It is faster, quicker, and more throughput device. That is the embedded system. One of the operational quality attributes is response. Response of embedded system should be very quicker, fast result. It should be track inputs very quickly. So the people's customers are required this type of important quality. And another important quality of this embedded system is throughput. Throughput means it is as like a efficiency. Efficiency of the system should be very high, compiled within the specific time. Efficiency means we can measure whatever the complex instruction or complex program we can execute it within the specific time, then naturally the throughput of a system is increased. Otherwise, out of the time we are not getting a specific output, then the output is totally decreased. So embedded system which is avoid this type of delay, then that will give the maximum efficiency of the system, and almost all the complex operations also executing within the specific time. And another important operational quality attributes is reliability. Reliability is the most important factor. It is a probabilistic approach. Probability means success as well as the failure. Suppose you can design any one system, we cannot tell how many days it will survive. That is depends on the situation, and so many parameters are governing. We cannot tell it, but probabilistic approach we can tell the probability which is depends on MTBF. MTBF means mean time between failure and mean time to repair. How much failure between one system into another system. For example, there are two types of systems. Systems you can connect it in series, the reliability is less. Suppose one system is fails, entire line will be collapsed in series connections. So that series connection can connect the number of system, that is not useful. But you can connect the systems in parallel, that should be way more reliable and more efficiency. So we can calculate these probabilities based on the success and failure. So we can measure the only two parameters which is known as mean time between failure and mean time to repair, MTTR. These two parameters we can utilize it mathematically. It is a type of mathematics. We can calculate the probability of errors, probability, entropy, and so many parameters we can design. In this way, the system is said to be more reliable, means it is the lifetime is more. The system is less reliable, lifetime is very less, failure is more. So in this way, reliability can be measured in embedded system design. We are testing different types of design and its failure and life of the system also most important characteristics of embedded system design. Correct ಬರ್ತೈತೆ. So another important characteristics of quality attributes, that is maintainability. Maintainability means any embedded systems you can design it, you can sell the systems to the customer. So maintenance is most important. Very easy to maintainable and low cost. Such a type of systems the peoples are required, the customers are required. Maintainability is one of the interesting, and it is one art to maintain the systems of embedded systems. Both software is there as well as hardware is there. You have to manage certain degree temperature and pressure. The system will be more durable. So maintainability is also one of the most important quality in embedded system. And another most important quality attributes is security. Everybody prepared the security. Without security, they are not, the customers are not purchase any equipment, especially for networking systems. Almost all the ATM machines, so many things, they are required very secured. Whatever your investment should be very secure without any misusing. So security is most important in case of embedded systems. So all the networking systems, they are built firewalls for the security aspects. ATM that build up, so many processes are there, so many transactions are takes place before discharging to the money. So these are the security alerts, and security things are most important in case of embedded system design. So nowadays the peoples are required very secured systems. So another important is safety. Safety is also one of biggest task. About the your systems or your data should be very secured and safety. So safety facilities are providing the embedded system designer. So these are the operational attributes. Now we are enter another type of attributes which is known as non-operational attributes. These are not functions. Non-functions attributes are known as non-operational attributes. In non-attributes, they are for number one, testability and debug ability. It is like a quality assurance department. What happens, your product before dispatching to the outside world or marketing, it is undergoing the quality assurance sections. So that there your software is tested. If any something is going to wrong, debug that things again. They are sending to the R&D department. Again, they will any modifications, then complete that task, then only they are provide the certificate. Testability and debugability is most important in case of embedded system design. So they are providing number two, debug facilities for both software as well as hardware. There are specific devices are there to test the software as well as test the hardware, the component level, chip level, all facilities they are providing. Engineers are providing for embedded system design. So this facilities is also most important attributes in non-operational system. And third one is evaluability. Evaluability is closely which is related to biology, non-variable inheritance. The continuous evaluations is most important in case of embedded system design. And another most important attributes is portability. Portability, I already told, the peoples or customers are required. Compact size, effective cost, and lightweight. All these parameters are required. Embedded system should be very portable. Then only the peoples are prepared. So many portable Android mobiles are there. So many devices are available at present market. And another important attribute is time to prototype and market. Suppose if you are produce different type of products, then market is also very important. The competitive market, so many people are participating in the same products at that time. Your product should be competitive in the competitive market. Then only you are under profit. Otherwise, you are under loss. Because nowadays so many companies are design and develop the embedded systems. The peoples are required, both they are prepared, quality as well as effective cost also they are prepared. Suppose if your product is exist in the competitive market, then you are one of the good designer in the market. And last non-operational attributes is unit cost for revenue. So if you design and develop your system, that there you can evaluate in different parameters, market strategies also most important, and how much cost you have to fix for your system, and other companies rate also you have to bring into the picture in competitive market, and then only your system will be sell, then customer will be purchased. Then collection of the revenue is most important for the designing issues. So these are the important non-operational attributes.